Just before we start, can I just ask, are you sort of involved in networking within the infrastructure, or are you just generally interested in the impact of it as a...
yeah, I got the system administrator, so...
Okay. You're a sysadmin?
Yeah.
Yeah. So on the Linux side?
Linux,
yeah.
Linux.
Okay. Are any of you Linux or Linux admins? Sysadmins? Okay. The reason for that question will come evident as we go through it. I mean, so this is such a small group of us, let's just keep it as interactive as possible, because otherwise I'll just end up preaching about what I want to talk about, and it may well not be what you want to listen to. So, has anybody heard of Arista before? Has anybody heard of Cisco before? Yeah, okay, alright. Well, most people have heard of Cisco. I mean, just to set the scene, Arista is an Ethernet switch vendor, so we manufacture Ethernet switches. The difference between us and most of the other vendors out there is we do specifically focus on two key areas. One primarily is the data center. Okay, so our switches tend to reside in the data center. But the second aspect of our focus is we focus pretty much exclusively on big data. So we don't really provide infrastructure or switches that will support, your email or that kind of environment. There really isn't the amount of bandwidth demand that would justify you spending money on Arista. Where Arista really makes a difference is where there's a lot of data. So big data, whether that be high performance computing or with the visual effects market. So we go through that. And really the intention of today is just really to draw your attention to some of the gotchas that we've seen as we've worked with companies in this vertical market. And really just provide some insight into where the markets are going, what the industry drivers are, and what you really can see from it. Just to give you some background on Arista, we're probably the newest networking vendor that's out there today. We were only founded back in 2004, and the first product started shipping back in 2008. So we've only been shipping for just coming up to 4 years now. So compared to the traditional competitors that we compete against, who started shipping back in the 80s, we're relatively new. I'll explain some more about the reason why there was a 4-year gap between when we were founded and when we started shipping. I'll also give you some background on the management team, because irrespective of whether you've heard of them personally as names, you will have been tracking the careers of the senior management team at Arista over the years. So we'll go through that. Arista is an undoubted success story. Whichever of the blogs you read about, you'll see that Arista has had quite a dramatic rise and impact in those 4 years. To the stage where our goal was 1,000 customers in 1,000 days. We've already exceeded, I think it's about 1,600 or 1,700 customers globally in less than 4 years. And if you track that against the typical companies of our size, that's quite fundamental. And it's sort of backed up by the fact that in terms of 10 gigabit Ethernet, we're already a number 2 in the market share, or in the market space. And we'll talk some more about. I mean, you've got to have your reward, the logos of the awards you want out there. Otherwise, it doesn't seem like a corporate presentation sometimes. But to give you some idea about the people who are behind Arista, so I said that you've been tracking their careers, whether you heard it or not. So you've heard of Sun Microsystems. I guess most of you have heard of Sun Microsystems, the server vendor. Well, one of our 2 founders, Sandy, was the founder of Sun Microsystems back in the day. So after he founded Sun Microsystems, he then went on to join forces with David Sheraton, who's still Professor of Computer Science at Stanford University in California. And they formed a company called Granite. So the next stage of their careers that you may have heard of is that they formed a company called Granite, which they sold to Cisco. So if you've ever used the Catalyst 4000 range of products, that is actually derived from the initial investment that Cisco made in David and Andy's company. So if you've not come across Cisco and the Catalyst 4000 range, you will have heard of them because they were the first guys to put any money into a company called Google. All right, so they were the original guys who wrote the first 2 checks to fund the incorporation of Google. And there is, I don't know whether it's a true story, he's never told me, but there's a true story that Google is spelled G-O-O-G-I-E rather than G-O-O-G-A-L, which is the traditional spelling of Google, because when Andy wrote the first check for Google around his dining room table, he misspelled it, but that's maybe hearsay. So they funded Google. Obviously, these companies they've started obviously generated huge amounts of cash, which is all very nice for those guys. But the important thing and the important thing it means for Arista is that there is actually no venture capital in Arista. So there's no banking organisations behind Arista. The company was founded based on these 2 guys' own personal credit. And the reason why that's important is because if you started by a venture capitalist, what will traditionally happen is that the company, or the venture capital company, will look for you to get to market within 12 to 18 months with a product to demonstrate that their money that they've invested in you is actually a solid investment. And what that means for venture capital funded companies is you tend to cut corners on the original good idea to try and get it to market as quickly as possible. Whereas having these two guys cutting us a line of credit for 4 years meant that we didn't have any checks. We could spend 4 years getting the architecture of Arista products right. And that's quite important, because if you get the architecture right from the very outset, then it means that you can build some real success. Since then, the guys have invested, been very good investors in companies, well-known companies like VMware, Brocade, Tripping Point, and to name but a very few. So they are out-and-out engineers. They're not they're not wealthy men. They're incredibly wealthy men, but they're not driven by cash. They're driven by their interest in technology and movements of technology. Third person is Jay Shree. She joins as our CEO, and she is well known for driven the majority of Cisco's revenues over the years. So very well known in the industry. The other nice thing about having these guys involved in the company as well, that they attract very capable engineers to join the people who want to work with them. So we've got some incredible engineers who are behind many of the industry standards, multicast, spanning tree, SMP, all these well-known industry technologies driven by engineers who now work for us. So again, just to be clear, we as a vendor, we don't focus on all the markets that are out there. We tend to focus on markets where we can make a difference. Traditionally, we're well known for high-frequency trading. That's an area of the city operating in London and Frankfurt and New York. So financial services, where they have these algorithmic trading engines where they trade on the open markets at very, very high frequency, and latency is very, very critical to them. And Arista has the lowest latency switches, so we're the darling of the financial services market. But equally high-tech manufacturing, give you some idea, organisations like ARM, the processor vendors, are Arista customer. But in the VFX industry particularly, we've got a very strong install base, because we can make a difference to those organisations. We can make a difference to the speed at which they can create content, and ultimately that makes a difference to the time to market for these feature films that these organisations are working on. We'll focus on that predominantly after this. But equally well-known in science, Web 2.0, the big hosting companies, as well as the geophysics and organisations like that. Really anyone who's got high-performance computing, huge amounts of storage, or huge amounts of virtualisation, and this is a solution for them. And I won't bore you to death with our markets, but certainly within this space, we're very well known. To give you some idea, the organisations locally in London who use us, it's the likes of the Double Negatives, the Frame Stores, and if we go further afield, it's the likes of Pixar, Disney, Dolby, Weta Digital, obviously the Lord of the Rings and the trilogies and the latest The Hobbit. This is all being created on Arista products, the whole of the Harry Potter series, etc. So it was quite interesting. We did a little survey with the company. I was going to put a slide together for something more organised, just to show you the nature of the feature films that have actually been created on Arista infrastructures, and it's really all the major films you're talking about at the moment, from the latest James Bond right through to the Harry Potters and the Hobbit and the Lord of the Rings. So, just to focus on some of the things that we're seeing out there in terms of the challenges that are facing most of these visual effects companies that we're dealing with. First of all, just on a very basic level, is the cost of the data centre that they're operating in. Power, space, downtime, those are the key metrics that these guys are looking at. If you want to host a data centre in Wardour Street, the first challenge you're going to hit is power. There's not enough power, and certainly with the effect of the Olympics, there's even less than there was previously. So having infrastructure that reduces the amount of power that is required makes a massive difference. Clearly in any data centre as well, space is at a premium. So the smaller the footprint of Ethernet switches, the more servers in the render farm you can fit, and therefore there's a massive advantage that you've got there. And clearly downtime. Downtime is the enemy of the visual effects company now. Visual effects companies are increasingly operating on a 24/7 operation. They may not be manned 24/7, but the jobs they're running, the rendering that they're running, is operating on a 24/7. So any downtime seriously affects the time to market and the release of these films. And so downtime is everything. What we're also seeing is an increased I/O per server. We'll talk about the way that server performance is increasing dramatically by something determined by something called Moore's law. But we're seeing the increase of I/O to the server increasing rapidly to the level that from sort of this year moving forward, the predominance of the I/O for a server will become 10 gigabit Ethernet. You will pretty much not be able to buy a high-end server without a 10 gigabit Ethernet interface in it, so you might want to boost it. Clearly, from the VFX industry as well, the time to market is crucial. You want to get these films to the market to generate an income for the film companies as quickly as possible. So the less time it takes to render and create these visual effects in the film, the better it is and the better the proposition of the VFX industry or VFX company. Clearly, the volumes of data involved in VFX is increasing, whether it be because of 3D, high res, or just the physical amount of visual effects that are involved in typical films these days. It's just increasing the volumes of data. That data tends to be quite bursty in profile. It's not solid and continuous traffic levels. It's quite bursty levels of traffic. And then from a cost of ownership perspective, these organisations are trying to derive as much value from the kit that they buy. So the longer they can make use of it, the better the return on the investment they can get. And the final thing that we're seeing in these environments is that whether you like it or not, whether you believe that Ethernet is a good technology, Ethernet is the technology that's going to win. Whether it be on the storage side, the network side, or whatever, it's going to be the technology of choice. We don't really have a tricky call in that. It's really just the dynamics of the market and the amount of investment that Ethernet is that takes it forward at a faster rate than everything else. So, when we're looking at the network infrastructure in the visual effects company, what we're actually looking at in terms of measure of the success of the deployment and the performance of the deployment is the measure is actually good put. What we term is good put, not throughput. Not the amount of data we get going in through an interface and out through an interface. It's actually the amount of data we get from the original workstation through to the storage node or the render node. That's really the measure of success of the infrastructure. And so when we look at the traditional networks that people have deployed, what we're increasingly seeing in terms of the network, the physical network infrastructure, if you look at it, it's a series of really workstations. These are the creatives creating the content. This is the render farm where we're processing the content, we're creating the effects, and obviously storage as well. And if we look at the way it's typically connected today, pretty much every end node is connected at 1 gig, and increasingly what we're seeing is in there is a 10 gig core. Now from a networking perspective, the network people in the room, what you'll probably remember or realise is that the challenges typically is the core of the network is probably quite limited in terms of the number of ports it has and the bandwidth, primarily driven by cost. The 1 gig nodes want to interface into that 10 gig, but the connectivity in this 10 gig core is pretty basic using technologies like spanning tree, which automatically mean that at least 50% of your network connectivity that you pay good money for is actually not active. It's sitting there waiting for a failure in the network. And so what you're seeing is limitations throughout this infrastructure, which is basically limiting the connectivity from your creatives through to your render farm and to your storage nodes. What we're also seeing is some challenges that frequently are not actually identified but are actually causing major problems in this transfer of data through the various nodes. Because if you're taking data from, I said before, sorry, just to step back, I said before that Ethernet is going to win, whether you like it or not, and whether it be the best technology or not. That's a fact of life, just because the amount of money being spent on Ethernet and the way that it's being developed. However, Ethernet is actually very, very dumb technology. Okay, there's lots of communication technology out there that are much more intelligent and capable of transferring data on a good basis. Ethernet isn't. Ethernet has got no end-to-end connectivity understanding. All it knows is the bandwidth that the particular interface has, and it will use as much or as little as that as it possibly can. Okay, so if you transmit any data out of a 10 gig attached device and try and send it to a 1 gig device, you're going to have problems. And the typical challenge that most people overlook is one of buffers. And it's a very, very basic and simple concept to consider. In the fact that if you pour a big jug of water into the top of a funnel, what's going to happen is a certain amount of it will go through the funnel and a lot of it will spill over the edges. And exactly that is happening in a lot of visual effects environments at the moment. Traditionally, it's things like storage devices which become network connected at 10 gig first. Storage devices are very effective at driving high rates of I/O. And so people connect the storage device at 10 gig. And what they actually find is that the performance they're getting out of their network is only as good as, if not worse, than when the storage device was connected at 1 gig. And, and the problem is that the switch has no capability of buffering within it, and so as the data comes in, it transmits what it can, and what it can't, it just drops. And the net result is really poor performance in the infrastructure. And so for the people who actually made the investment, you've made the investment in upgrading your network to 10 gig and actually getting poorer performance than you had before. The way, for instance, that we build switches is we build them with huge buffers in there. And what happens then is you pour the data in at one end, the switch can accommodate it while it trickles it out to the end client. So I'll just move ahead to some of the key drivers for change in networking terms, and this applies probably more to areas like VFX or how you can performance computing than other areas, where the volume of data is the big challenge. Have you come across Moore's Law before? Okay. Moore came up with this concept back in about very early 1970s, that processors for servers, etc., would typically double in performance every 2 years. What he actually said was the number of transistors that you'd be able to fit on a silicon chip would double every 2 years, but it actually applies to the performance of processors will double every 2 years. And whilst he set that out in 1970, as you can see from the graph, he's actually pretty much hit the nail on the head. Every 2 years you'll find that the processor doubles in performance. Okay? So the impact on the render farm is quite dramatic, because it actually means that now, that to get the most efficient environment to drive your render farm, you've actually got to start looking at technology refresh on a fairly regular basis. And what we're typically seeing in the large VFX houses now is the lifespan of a typical render node will be 2 to 3 years. After that, it's using too much power, taking up too much space, and isn't performance enough. So it's natural time to refresh. All right? And the powers that be, the eggheads over in California, where else they're developing these chips, or in Cambridge, they perceive that this is only going to continue, if not get worse. However, from a network perspective, whilst I think it's, what does it say, in 12 years the CPU has seen a 64-fold increase in performance. In the same 12 years, the network has only increased 10-fold. So what we're seeing is the network infrastructure has been falling way behind the performance capability of the processor within the server. Net result is the network's becoming the bottleneck. All right? So what's changing the dynamics of that? Well, one of the big things that's held up the adoption of technologies, faster Ethernet technologies like 10 gig. Don't worry, you've got plenty of space. Yep. It's nice and warm in here as well, so you can. So one of the big things that's been limiting the adoption of 10 gig Ethernet has been really that of cost. And the fact that if you typically wanted to connect a 10 gig attached server to a network, first you've got to buy a very expensive 10 gigabit Ethernet switch. Then you've got to use fibre optic connectivity to connect it from the switch to the server. Then what you've got to do is you've got to buy typically two very expensive, you've got to buy two very expensive 10 gig Ethernet adapters, which can cost as much as $500 a piece, to actually provide the connectivity from the server to the network. All right, so you're talking about a huge investment. Well, all that is going to change, because organisations like Intel have now introduced very, very cost-effective, power-efficient adapters that are actually built into the motherboard of most servers now. So, as I mentioned before, what you're going to see from this year onwards is the majority of medium to high-end servers will come fully 10 gig enabled out of the box with no additional investment. Not only that, but the 10 gig interfaces they will provide will be UTP, unshielded twisted pair, which is the typical cabling plant you've already got installed in your data center or to your clients. That, coupled with the fact that you've now got much more cost-effective Ethernet switches, means the cost of adoption of 10 gig Ethernet is now coming down. So the interface is coming down, the connectivity is coming down, the servers are coming with it, and the service performance is increasing, so it's natural now to start contemplating the adoption of 10 gig Ethernet. The other thing is that if you start to look at the lifetime expectancy of the various technologies in your infrastructure, anybody in networking will probably recognise this, and it's probably conservative to say the least, But when you install your cabling, your UTP cabling or your fibre cabling, you'll typically look at a return on investment. You'll typically look for that to last between 10 to 15 years after you install it. It's expensive to do, so you want to make it last as long as possible. Your switching infrastructure, you'll probably want your switches to last a minimum of 5 years. Okay? The problem is that your servers, as we've talked about due to Moore's law and various other things, will typically last about 3 years, okay, before they become deemed inefficient and non-performant. So if you invest in everything at the same time, it's quite important that your switches are able to accommodate technology refresh on your server level. Otherwise, you're just simply going to shorten the lifespan of your switch. All right? So based on your knowledge that your next generation servers are actually going to be 10 gig connected, it's probably quite intelligent now to start thinking about investing about 10 gig connectivity to the edge of your network if you're going to take advantage of that. Otherwise, you're simply going to shorten the lifespan of that Ethernet switch that you're investing in. So just to underline the way that the industry is going, and these are not Arista figures, these are Galoro, and I'll provide a variety of them on. And with them being consultancy firms like this, they'll probably contradict each other wildly as we go through it. But these are basically the revenues of that the industry expects to see from the various technologies. But what you can clearly see from 2012, 2013, that whilst 1 gig Ethernet maintains a level of investment, what you're increasingly seeing is the adoption of 10 gig taking more and more of the overall market. And back to the point about why Ethernet's going to be successful. The reason Ethernet is going to be successful is it is at least a $21 billion a year technology. Okay, so over $21 billion a year is spent on Ethernet technologies. So if you work on the basis that typically in industry, 5% of that goes back into research and development as a minimum. It will vary between vendors. Places like Arista will be higher, at places like, I don't know, desktop switch vendors will be lower. But 5% goes back in. If you compare that to markets like InfiniBand, which is about $150 million a year of spend, then there's no way that the investments in things like InfiniBand can ever keep pace with the investments in technologies like Ethernet, because there's just so much more money going back into it. If we now look at the attach rate on servers by port speed, again, what this is just demonstrating is that the adoption of 10 gig is going to become the majority of the server connectivity over the next year, 2 years, 3 years. Okay, so the predominance of servers will become 10 gigabit Ethernet. And you can see that the port shipments of these LAN and motherboard interfaces are just going through the roof already. And just another switch breakdown. This is quite interesting because what it's also demonstrating is that the rate of the port shipments are growing dramatically, but the market adoption of 10 gig over UTP is just going to be the biggest adoption of all technologies. So it's going to be 10 gig over UTP, but it's going to be the predominance of interfaces shipped, and that's primarily because all the edge of the network in high performance environments such as VFX will become 10 gig over UTP. All right. There's a slide. So yeah, it's really just summarising the fact that the server will be connected by 10 gigabit Ethernet over the near future. And if you're going to manage your cost base, then really you've got to start thinking about the switching infrastructure. Does this make sense? Is this? Yeah. Storage is another interesting one. Back to rather like InfiniBand, a lot of people believe in fibre channel as being a technology for storage, and certainly it's a very efficient way of connecting storage nodes to servers. However, what the industry is now seeing is that, again, the fibre channel market is so much smaller than Ethernet, that actually Ethernet will become the predominant connectivity of choice. So network-attached storage uses Ethernet as an interconnect, and will become the technology of choice, primarily because of the investments in Ethernet and the fact that it will just grow and scale in terms of performance far faster than any other technology can. Okay. So that's really where the market is, and just I'd like to finish really with just a brief introduction to Arista and on what's different about Arista, because the networking space is very busy. There's lots of vendors out there. You know, everybody's heard of the Cisco's and organisations like that. However, Arista has been able to carve out a niche in the market space very, very effectively in a very short time. There's some very specific reasons. First of all, very quickly, when we first set out, we decided that we weren't going to build our own silicon. We weren't going to build our own silicon chips to act as the core switching engine of our switches. In 2004, it was evident that commercially available silicon is very, very effective at fulfilling that role, very, very feature rich, and so there's no point in spending $50 million of our own money and 5 years of development to create this technology when it's actually out there. Traditionally, all switch vendors have built their own silicon, so we made quite a different change there. So the second thing was we decided very specifically we're going to build our switches for big data and the data center. So we don't need to worry about the issues at the typical user connectivity, things like voice over IP or other technologies that exist at the network. All we're interested in big bandwidth and high performance infrastructures. And the final thing is we decided that the monolithic operating systems that have been created by the likes of Cisco were actually their biggest Achilles heel. They were difficult to develop and they were highly unreliable and caused untold amounts of downtime. But equally, they were very inflexible and very closed. And what we wanted to do was build an operating system that was entirely open and scalable, whilst also delivering a high degree of system availability and resilience. So it's no secret actually that an Arista switch, an Arista Ethernet switch, is in fact just a Linux server with a very fast Ethernet card in the front of it. We run a full copy for all 14 within switch. And actually we don't stop or limit your access to that. In fact, we positively encourage it. If you can make better use of an Arista switch by loading applications and services or writing scripts, then we'll fully support you in that process, whilst also making sure that it doesn't compromise the primary role that you bought it for, which is acting as a very high performance Ethernet switch. All right? So you can go on our command line, which for very sensible reasons looks and feels like the absolute industry standard. Anybody who's a networking engineer will have no problem picking up an Arista switch and running with it. But equally from that industry standard command line, you can type bash and be straight into the shell of the switch, and you can use the Python scripting tools that are on there or anything else from the switch to make that switch operate and deliver the services that you want. Now if you think about the traditional switches, which are very closed and locked down, that's quite a revolution. However, the reason we built it this way was because it was not really the openness and extensibility. It was the fact that we wanted to build a reliable switch that delivered service. Okay, and so to that end, the actual reason we ran it on Linux was because one, it was the most trusted operating system in the data center. But secondly, it enables us to run all the processes on the switch in their own protected memory space. So it's not that house of cards that traditional switch vendors have suffered from, where one process has a problem and the switch goes over. Once the switch goes over, it reboots. Now you've got no data on what caused the problem, and so the typical support call is upgrade to the latest version of code, or let's see whether it happens again. Both scenarios are equally unacceptable for most organisations these days where you're running a 24/7 business. With the Arista switch, what we do is we separate all of them into their own protected memory space. Any single failure will not cause any impact on any other switch. We also take the state of every individual process on the switch and keep that in a centralised database. And now every process simply subscribes and publishes information to that central database. So for instance, we can in-service patch any of these processes. Any process can fail and can be respawned automatically, but when it is respawned, it simply takes its state as it was before it failed and starts from a known point. Okay? So again, it's all about service availability. But equally, just some slides that demonstrate anybody who's a network engineer will just recognise this CLI as being what they typically got from their Cisco switches, if that's what you've traditionally used. But equally, anybody who's a Linux expert will realise that it's under the hood, it is a Linux server. So you get a lot more data out of an Arista switch in terms of failure scenarios or problems or whatever else, so infinitely more supportable and serviceable. And we've even taken it to the next level. So we recognise that increasingly people do want to run services on the switches. It may be a level of automation, polling default gateways or service nodes in the network to try and determine failure scenarios very, very quickly to create failover. But what we've also done is people want to run applications on the switches. So now you can get Arista switches with 50 gig SSD built into them, so that you can actually have a storage environment in your network switch, so that you can store your data on it, or your application or your service on the switch in the network. The next thing we do is we build networks that deliver the service, the performance, and the general dynamics required to support the infrastructure that you're looking to build for a visual effects company. So what we provide is for where service nodes or where workstations, where the creatives are actually creating the content. We do provide 1 gigabit Ethernet switches to provide the connectivity for what's already there. But the important thing is here, within those switches, we put huge amounts of buffer to manage this transition that we're talking about between the 1 gig world and the 10 gig world, to make sure we don't drop packets. Another thing about TCP/IP or TCP in general, if you start dropping packets, it has a major impact on performance, because TCP eventually backs off and reduces the amount of traffic that can go through a connection. So drop packets are a very painful thing to happen. They'll reduce the performance of your environment dramatically. So we provide switches with deep buffers that accommodate that transition between 1 and 10. We also provide high density switches, which can provide enormous density of connectivity without any compromise to performance. So to give you some metrics, we build a 1 RU switch with 64 ports of wide-speed non-block 10 gig, a 1 RU switch. Equally, we build 7 slots and even 11 slot switches, which will accommodate up to 368 ports of wide-speed non-block 10 gig with big buffers. And as of early next year, that will increase to over 1,100 10 gig Ethernet ports in a very small physical footprint. So we can accommodate the growth. Now, if we look at the way that Framestore, Double Negative are actually building their infrastructures, what they've actually done, because these switches also have very high density as well, is they've actually shrunk this. These switches are actually, for the render farm, are actually part of the chassis-based server environment that they buy, and then they simply uplink them into very high density 10 gig switches in the core to accommodate that sort of that port density they need. But then increasingly what we're seeing is out here 1 gig, predominantly 10 gig attached storage, and the connectivity options that you need. The other issue that we overcome as well is this multi-link multi-chassis link aggregation technology, MLAG. What it enables us to do is to build multiple connections, resilient connections, even at layer 2, where we have an active connectivity. So what we're trying to say here is, in the old world, you have one switch port connected that's live, another switch port that's connected that's in standby, it's down, it's waiting for the failure of the primary connection. Well, that's very, very inefficient. You're buying 2 ports and only using 1 at any one stage, so it's not very effective and doesn't provide a power performance scale. With what we do is we have the ability to have both live at the same time. One fails, we've still got a secondary one there for resilience, but why not make use of both of them so you get the best performance for the money that you're investing. So a very, very active, layer 2, layer 3, low latency, high performance, and an ability to scale out. What we're seeing within all the big render farms and the smaller render farms is they're only growing, they're not shrinking. And so you've got to have that ability to grow with your infrastructure without hitting major investment points all the way through the development of the infrastructure. And finally, just a good diagram of the impact of buffers. What we see here is testing that we did in a visual effects organisation, where here we're scaling the throughput and here we're scaling the number of devices. And as you can see, as you scale the throughput with the number of devices, the performance actually drops off on a traditional switch. Whereas with the Arista switch, because of this buffering, you're able to maintain a significantly higher level of throughput through the infrastructure because of the effect of these buffers on the data transitioning through the network. And the final slide, you may be delighted to hear, is just obviously we build boxes, we build a variety of boxes. The nice thing from an Arista perspective is though that whilst they come in all sorts of shapes, sizes and interface types, they all run exactly the same version of operating system, which means that actually you get a consistent level of features and functionality whichever box you buy. So what you can do from an Arista perspective is buy the box that makes sense for what you're trying to achieve, rather than having to balance the box with the functionality that you're trying to deliver. Okay? So traditionally with switch vendors, if you really want high functionality, you have to go for the big chassis-based solutions. You weren't able to take advantage of the more cost-effective, smaller port density boxes that maybe would actually fit the environment from a port density perspective. That's not the case with Arista. Every box does everything. There are some slight variations, but in principle, everything does exactly the same. So now what you can do, if you're a smaller VFX house, starting off small but looking to grow, you can make the right investment at the right time. but full in the knowledge that you'll be able to grow into a much bigger box if you're as successful as obviously your investors hope that you're going to do. So, to summarise, really, from a networking perspective, in high performance environments such as visual effects, well, outside of that as well, Ethernet is going to be the technology. It's already developed, it's already defeated many technologies already. Many technologies, looking at the age of most of you in the room, you've probably never even heard of, but the technologies such as FDDI, token ring, ATM, these technologies all happened and disappeared because Ethernet actually came. It's a bit of a Betamax versus VHS, you know, token ring was a better technology, but like Betamax was better technology than VHS, but unfortunately VHS won the day just because of the amount of investment that went into it. In exactly the same way, Ethernet is going to be the technology of choice for most organisations. The next thing is, you are in the middle of this, or at the start of the migration from 1 gigabit Ethernet to 10 gigabit Ethernet. 10 gigabit is going to become the technology of choice. Initially to the servers, to the storage devices, but increasingly from now on to the servers. And you've got to start making decisions that bear that in mind, because if you start investing huge amounts of money in 1 gig technology, then effectively you're going to rule yourself out from taking the performance of the new servers that you're going to get, or you're simply going to have to reinvest in some of the technologies earlier than your investment cycles would probably predict. In these environments, it's clear performance does make a difference. The higher performance of the infrastructure, whether it be servers, network or storage, will improve your time to market in terms of the visual effects or whatever else you're trying to deliver. But the true measurement is good put, it's not throughput. How much real data is getting end to end, and how good is the performance of the overall application. Okay, and that's the careful consideration. As we've seen from Moore's law, historically the servers have been increasing in performance much faster than the network. It's time for that to catch up, and that's why 10 gig Ethernet is going to increase. But predominantly with 10 gig over UTP. The reason is it's more cost effective, it protects the investment in the cable plant that you've already got in place, and so the overall cost of adoption is much easier to justify. And finally, you know, the traditional network architecture that people build really don't suit the nature of the networks that need to be deployed in these high bandwidth environments. You need to start looking at different architectures, and that means active-active connectivity from at all points of the network to make the most use of the bandwidth you've got, but also networks that can scale dramatically, and that's exactly what Arista is there to do. So, very, very quickly, is there any questions? Did anybody understand a word of what I just talked about? Was it nice and warm? Okay. Well, we got the stand. You'll probably be the first people to the coffee and the biscuits, so there's an advantage to coming to this session if nothing else. We've got a stand outside with some giveaways, and if there is any questions that you want to raise with us, please